All right, in this example, we are going to integrate tangent to the fourth power of x. This is example 6 in our series of trig integration. So let's go to our guidelines. We have a situation where there are no secant factors and the power of the tangent is even and positive. So we're going to convert tangent squared factors into secant squared factors and expand as necessary. So go back to this example. So we have, we're going to take, and we have limits of integration here, so we have a definite integral. Let me break that down a little slower here. Let's say, you can rewrite tangent to the fourth as tangent squared times another tangent squared dx. I'm going to convert one of these into a secant squared minus 1. Secant squared x minus 1, that is a Pythagorean identity. And now what we can do with that is we can distribute our tangent squared. And we have from 0 to pi over 4 secant squared x tangent squared x and minus tangent squared x dx. Now what I can do is I can split this up, and I'm going to switch this around a little bit. I'm going to put tangent squared x times secant squared x, just interchanging these two. Smiley face there. And then I'm going to split these two integrals up. So I have tangent squared x dx over here. All right. So I still have an even power of tangent here. In this situation, I can use u substitution to integrate that. So I'm going to leave that for right now and just rewrite this here. I have tangent squared x, secant squared x. In fact, you should pause the video and integrate this right now and then check to see if you are doing it correctly when you get back. And then over here, I'm going to substitute in secant squared x minus 1, that Pythagorean identity, because the secant squared x has an antiderivative of tangent. So that should be relatively easy to integrate. All right, so this first piece here, we have, if we let u, cooperate with me please, computer, u, there we go, equals tangent of x, then our du is secant squared x dx, which is right here. So I will be able to use u substitution to integrate this first one. So I have, this becomes u squared du, and then minus, and you can split this up if you want to, oops, secant squared x, and then minus a negative 1 becomes plus 1 dx, or just dx. All right, so we end up with u cubed over 3 minus tangent of x, because the antiderivative of secant is tangent, plus x. And we're going to integrate that from 0 to pi over 4. All right, so my u was tangent, so I have tangent cubed x over 3 minus tangent of x plus x. Okay, and our last step here is we need to plug in our upper limit of integration, pi over 4, and we're going to subtract the lower limit of integration, 0. So be thinking about what the tangent of pi over 4 is equal to. And now I'm going to put 0 in here. What is the tangent of 0? Hopefully you know that. But the tangent of pi over 4, recall, is pi over 4. So 45, 45, 90. I get the ratio of sides is 1, 1, and the hypotenuse would be square root of 2. The opposite to adjacent, which is our tangent, is 1 to 1. So we have 1 cubed, which is 1, so this becomes 1/3 minus 1 plus pi over 4. And then the tangent of 0 is 0. So this entire second piece here is 0. And so when you work that through, 1/3 minus 1, which I can make into 3/3, is -2/3 plus pi over 4. And that's our answer in exact form. You can throw it in a calculator if you want to get the approximate value. All right, so that is example 6.